Good morning, everyone. Myself, Shivani. I am working as assistant professor in Marri Reddy Institute of Technology and Management. Today, we are going to discuss about the subject of strength of materials. These are the course objectives: to understand the concept of torsion and deflection of springs, and to understand the behavior of columns and struts for various columns and for loading conditions, to calculate the direct and bending stresses of members subjected to various loads, and to analyze the members for stability under sliding and overturning, and to evaluate the hoop and radial stress. And these are the course outcomes. After the successful completion of the course, students will able to learn and to analyze the effects of axial loading, composite bars, temperature stresses and strain energy under different loading conditions. And they will able to construct shear forces and bending moments, diagrams for determinant beams under various loading conditions, explain the bending and shear stress distribution in beams using relevant theories and formulas, and they are able to find the slope and deflection of beams using different analytical methods, and they are able to examine the state of stress on oblique plane and the different theories of failures. Syllabus, these are the syllabus. Unit 1 considers torsion of circular shafts and springs. Each unit has 2 topics, and the unit 2 has columns and struts and beam columns. Unit 3 has direct and bending stresses, and unit 4 has thin cylinders and thick cylinders. Unit 5 has unsymmetrical bending and shear center. Introduction of torsion. Torsion is the twisting of a structural members, which is usually a shaft, due to an applied torque or a twisting moment. It causes shear stresses and strain in the material, which varies linearly from the center to the outer surface of a member. Means, if you take a material, for example, if you are using a wrench to tighten a nut in a bolt, if a bolt, wrench and the force are perpendicular to one another, the twisting moment is the force times the length L of the wrench, that is torque is equals to force into perpendicular distance. These are the assumptions for torsion. Material is homogeneous and isotropic. If the material, if it is twisted, the same, if it is in the physical state, it is the same physical properties. It will have the same physical properties. Next one is shaft is circular in cross section. Next, it is a pure tension. That means no bending moments are applicable. Only twisting moments will be there. And next, shear stress distribution is linear from center to outer surface. Shaft. Shaft is a mechanical component. Usually, it is in the shape of a cylinder, used to transmit a power and a torque from one part of a machine to another. It is designed to withstand torsion, bending and sometimes axial loads during operation. For example, if you are riding a bicycle, the power is generated from our legs to the shaft, and then shaft and a cycle chain is going to generate the power, and the cycle is going to be move on to the front side. This is an example. Torsion loadings. See here, turbine and a generator. Interested in stresses and strains of a circular shaft subjected to twisting couples or torques. Turbine exerts torque to the shaft, and the shaft is going to be transmit the power, and the shaft transmit to the generator, and the generator creates an equal opposite torque. Torque. What is torque? Torque is the twisting force applied to the object, causing it to rotate about its axis. It is the moment of force that tends to produce torsion in a shaft or other member. The torsion equation, tau is equals to tau R by J. Tau is nothing but the shear stress. What is shear stress? Shear stress is a stress component that acts parallel or a tangential to the surface of a material. In torsion, the internal force acting per unit area resisting the twisting action. T is equals to applied torque. R is equals to radius at the point of interest. J is nothing but the polar moment of inertia. For circular section, the polar moment of inertia is pi d power 4 by 32. Introduction to power transmitted. Power is defined as rate of doing work. Okay, consider a shaft. If we consider a shaft which is subjected to a torque T and it is rotating of n revolutions per minute, that is RPM. speed of RPM. Taking second as a unit of time, time unit is second. Then angle of twist is defined as which torque moves is n by 60 into 2 pi, that is 2 pi n by 60. Power transmitted, power is equals to work done per second. Work done per second is equals to torque T, that is equal into 2 pi n by 60, that is torque. Torque is equals to next 2 pi nt by 60, or power is equals to force into distance. Force is W and distance is 2 pi Rn by 60, that is equals to WR into 2 pi n by 60, that is P is equals to power transmitted is equals to 2 pi nt by 60, where T is equals to W into R. Unit of power. The unit of torque is Newton meter. Then as usually the unit of power is Newton meter per second, that is watts. Since watt is a small quantity in practice, we usually what is a small quantity, then it is expressed in kilowatts, that is kW. In old practice, we need to express the power of unit is horsepower. Horsepower unit. It may be noted as 1 horsepower HP is equals to 0.746 kilowatts. Means 746 watts. In Newton meter per second is 746 Newton meter per second. We'll discuss a problem here. Determine the diameter of a solid shaft which will transmit 400 kilowatts at a 280 RPM. Then angle of twist must not be exceeded 1 degree per meter length, and maximum torsional shear stress is to be limited to 40 Newton per mm square. Assume modulus rigidity G is equals to 84 kilonewton per mm square. Here given data, power is equals to 400 kilowatts. Next, N is equals to 280 RPM. We need to find this torque, and the given G is equals to 84 kilonewton per meter square. See here, power. Formula for power is 2 pi nt by 60. Then power is 400 into 10 power 6 is equals to 2 pi into, what is the n revolutions? 280 RPM. 280 RPM. T we need to find out by 60. So we got this solution. We got here torque. Value of torque is 13.64 into 10 power of 6. From the consider of maximum shear stress, we need to find the maximum shear stress. The formula is T by J into QS by R. That is, we got the torque value in the previous slide, 13.64 into 10 power 6. Here, this is the torque value by J, polar moment of inertia. If we consider a circular shaft, this is the diameter D. The polar moment of inertia is, if we consider this is an x-axis, this is an y-axis, J is equals to pi into D4 4 by 32. This is the polar moment of inertia. This is the radius. If we consider this is the radius. Radius is equals to half of the diameter, 40. Then we got the smaller diameter value, that is 120 mm. From the consideration of maximum angle of twist, T by J is equals to G theta by L. We have considered in the question G is equals to 84 Newton per mm square. It is already given. We need to find what ma? Small d we need to find here, pi d power 4 by 32. So we have the torque value, J is equals to pi d power 4 by 32. L is already given, that is per 1 meter length, that is 1000 mm. Next, G is equals to 84,000. Angle is pi by 180 because it is a circular shaft, circular one. So D is equals to 98.67 mm. Then minimum diameter of the shaft to be used is small d. We got here 120 mm. and here we got 98.67 mm. So minimum diameter of the shaft to be used is 120 mm. These are the references, textbooks and reference books. Strength of materials by R.K. Rajput, S. Chen. Thank you.